Work done by the force field that, when a particle as it moves along the helix that, point 100 to point -103. Ooh. I haven't done these in a minute. I don't think they're that bad though. What's the actual question? I assume you need to use the point, so they're asking why they're given the point 100 and -103 pi. And I think that's because you need to find out what your t is from that when you parameterize your f. Yeah. So from here, I mean, you can tell kind of by like the z coordinate what things have to be because it's just a simple t. So if your first point has 0 for the z coordinate, then over here you probably have the 0 for your t, and that checks out because cosine of 0 is 1 and sine of 0 is 0. And over here your z coordinate is 3 pi, and cosine of 3 pi is -1 indeed, and sine of 3 pi is 0. So we expect our t's to range from 0 to 3 pi. And it's not the only question. I guess I don't really have to remember how a work integral actually works because I'm pretty confident that's the piece that they're missing. But even then, it's just the set f.dr, I'm sure. Hey, Skriddle. How's it going? Okay, I think that's all that needs to be said. You know, does Paul have a section on work integrals? I feel like there would be. Let me actually... In Calc 1, I wouldn't have thought to look there. Not scared, but scarred. Hey, Brian. So yeah, just force times distance, and wish it was in the multivariable context though, because it's more of a multivariable question. Does this count as a line integral? It is just a fancy line integral, isn't it? Oh, okay, that makes sense. It's something that's necessarily that fancy, just a different context. Okay, that's good to know. Yeah, because you do the work along the path, and the function that you integrate is your force. Okay. Hey, why is it red alert, Skriddle? You saw and had to click it? Oh, okay, I see. I get it. You see a big red button, you just gotta push it. Solids of revolution. Surprised no one's responded to this. To this? This? Only 16 points to go. Oh gosh. You're saving. Wait. So we have to revolve this function around the x-axis, and the function is already an integral function, so do we have to integrate twice? I wish I saw the entire question here. What do they do? Wait, when you solve revolution, you use the derivative? I don't... Okay, maybe I need to pause all my notes again. I'm rusty on these too, evidently. I thought the derivative was for arc length. No, yeah, it's just... The radius is the function value. This is arc length. That's the formula for our arc length right there, isn't it? 2 pi y. Unless it's some weird cylinder. No, because even then the... Let me look at the formula for arc length. Zoom this one up here. There it is. Well, no, that's... Okay, that's not exactly the surface area of revolution. That must be it, right? Like, that has to be it. Okay, there we go. That makes more sense. Oh, they even said surface area. Okay. I just can't read. Okay, so we need the surface area of the solid of revolution here. And that is why you need to get your dy by dx. And using the fundamental theorem of calculus, I assume it's just like a pop quiz to get students to apply the fundamental theorem of calculus. I don't... That is a good question, though. Because this part definitely confused me a lot at first, at whether, like, this is related to the solid revolution or to the integral. But I assume they're separate. But yeah, I guess if you derive this, you plug in... The integral and the derivative will basically cancel out, but you do have to plug in your bounds. So you do the upper bound, so you get x squared minus 1 square rooted, and then minus your lower bound. But you get 1 minus 1 is 0, so you don't need to worry about that. And so... Okay, so, which... I assume they're rotating about the x-axis if we're given bounds in terms of x. So we'd want to apply this formula, 2 pi y ds. Oh, this isn't going to be that pretty, is it? Because we do have to integrate this. Oh, that's mean. I mean, it's just going to be a trig sub with, I want to say tangent. No. Yeah? Might be secant, but it's one of those. It's kind of annoying, though, that they would give us a problem like this. I don't think there's a different way that you can do it, though. Okay. I guess let's try working this out, because I agree with their work up until this point, and I think they just are confused on what to do with the y. Unfortunately, the only thing I can see to do with the y is plug this function in, but it's not particularly helpful to have that if it's not already integrated for us, so let's try and do that. Okay, so if we do t equals, oh, I should actually look at the trig identities. Oh, Skirtle, okay. You know what, I'm even gonna rewrite this. Yep, I didn't even see that. The marker color must be honored. Okay, there we go. Okay, so now I want to look at the trig identities and remember how the secant tangent identity even works. I'm looking at this one right here. So if we have t squared minus 1. Oh, wait. Maybe it's... Is this actually a sign? I'm just getting mixed up. Throw me off when we have t squared minus 1. So let me just, okay, let's play it safe. I don't want to the wrong sub here. It's gonna be in the Calc 2 section. I don't like how they have the Calc 1, Calc 2 division. It's not how I was taught it, at least. So I don't. Oh no, I need to go to the next one. It is secant. Okay. Wait, but then why do they use secant like that? Wait, that format doesn't match. It's confusing. We have t squared minus 1. We get secant squared minus 1 equals tangent squared. Okay, that makes sense. Okay. It makes sense to me that it's secant. I'm confused by the example that they gave, but I probably just didn't read it enough and gave it the time of day to actually understand it. Okay. So let's do t equals secant theta. I don't know why I said secant like that, but I did. Oh, let me remember. I'm gonna do math super slow today. Secant theta, tan theta, d theta. And then we don't divide, we just multiply, so secant theta, tan theta root, secant squared theta minus 1, d theta. Okay, so secant squared theta minus 1 is tangent squared, and the square root of tangent squared is just tangent. So we get 1 to x, secant theta, tangent squared theta, d theta. Now with this, the best strategy here. Is this gonna be another one where you have to integrate secant cubed? I feel like I've been getting to that integral so many times the last few weeks, and I'm just not interested. Secant is 1 over cosine. Tangent is sine over cosine. Okay. Okay, I'm gonna Wolfram Alpha this because I want to see how complicated this integral gets. Hey, Spetri. Yeah, Zach, integrating secant cubed just doesn't... It looks a little mean. If we have x squared minus 1, I just want to give it the initial integral and see if Wolfram alpha agrees is my first step here. I might also look at the integral of secant cubed. Okay, yeah. Oh, yeah, they get into the secant cubed integral. Gosh. I'm definitely gonna look up what sub we want there. I'm not a huge fan of... they use this weird technique. But isn't this basically integration by parts? With secant squared and secant? Because that looks like a result from integration by parts, at least. And tangent derives to secant squared. So I think integration by parts actually isn't that bad. Okay, let's try that. It's a cyclic integral? Ooh, okay. Not too good, Spectry. I died very unceremoniously, but the team that I was playing with was full of cool people, so I can't complain. Oh wait, shoot, let me change it to be secant cubed minus secant. So tangent squared is equal to secant squared minus 1. So we get secant cubed theta minus secant theta d theta. Okay, so the integral of secant theta we can just look up, but the integral of secant cubed theta we technically need to work out. So let's do integration by parts. I'm going to set u equal to secant theta, because we're going to derive u, and then dv that we're going to integrate is going to be secant squared theta, because we know that's tangent d theta. So du is secant theta tangent theta. V is tangent theta, and then uv minus v du. That's how I always remember. I have to draw that arrow every time. Secant theta tangent theta minus secant theta tangent squared theta d theta. Oh! We had that right up there.
Always remember, if you ain't first,
hey, Jed.
you're last.
Okay, so I guess that's where it cycles. Oh yeah, I've been live for 20 minutes and no one saw that it was still there. Yeah. Okay, so now I'm going to make this again secant cubed minus secant. Cube theta minus secant theta d theta. And then because, or we can integrate term by term, and I do want to split up this integral into two different ones. Because this entire thing is equal to the integral of secant cubed, so we can group the secant cubes together. Secant theta tangent theta minus secant cubed theta plus, because minus a minus, secant theta d theta. Then I'm going to add the secant theta to the other side and divide everything by 2, so these equal signs are a little bit sloppy. One half secant theta tangent theta plus 1/2, no, integral secant theta, who knows that? So I think there have been 2 of those available today because I streamed two separate times. I thought Hardlock got the first one this morning when I went back to check my VOD. Oh, thank you, Zach. ln, and I'll deal with the constant of integration. I mean, it's a definite integral, so I'm not gonna worry about the constant. Oh, I'm being a little bit sloppy with it, but because I should have the bounds here too, but it's fine. Okay, so if we come all the way down here, famous last words. Yeah, yeah. I did just mess up a constant of integration too. So when I was doing a differential equations problem the other day, but I'm sure it'll be fine. So secant cubed theta integrates to this entire thing. We'd have another integral of secant theta, which is going to be ln secant theta plus tangent theta. So we're going to have minus ln secant theta tangent theta plus 1/2 ln secant theta tangent theta. Oh my god, dude, that's so hard to say. 1/2 secant theta tangent theta. So it's going to be -1 plus 1/2 is -1/2 ln secant theta plus tangent theta. Now we need to unsub. Hey, futures trader. Oh gosh, we just got 2 questions from chat coming in hot. Yes and yes to both of you, futures and aka Kapow. If you don't mind, just let me wrap up my train of thought with this integral that I'm working on here, and I'll get right to what you do have asked. Actually, so where was I? I was gonna, oh shoot. That's gonna be messy to unsub. Maybe I should just go right to your guys' questions, because it's gonna, yeah, trying to unsub this is gonna be a whole process. It's gonna take a while. So let me actually go right to, Futures Traders chat was first for me. So I'm gonna work on that integral, and then I'll go to Kapow. Actually, Kapow, I can give you a quick answer here. As my favorite notes website has a page on this. If I can find it. Where are my series at? Wait, where does the site go over series? Oh wait, it's in here, right? Oh, in the series and sequences section. That seems pretty obvious, but the quick explanation for the integral test for convergence is that if you can show that your series is positive and decreasing, you can integrate it from the first term to infinity, and if the integral converges, then so will the series, and vice versa. If the integral diverges, then so will the series. I can link you to this page as well if you want to read it more for yourself. That's kind of the quick and dirty of like how it actually works. So as long as you can show that you know, these conditions have been met, if you turn your series into a function, then you're allowed to just try to integrate it. Yeah, no worries. In general, I highly recommend this website because it has very clear explanations. In Future Trader, okay, thanks for making that correction. I bet this is going to be a U sub. I don't know exactly how it's going to go, so let's see if we can figure it out together. Make a nice dotted line here. We'll come back to this work later. It's not really, I have a priority. And I lost my train of thought anyway, so who cares? We want to integrate root 1+x over root 1 - x dx. Okay, good. Let's make sure I have that right. Thanks for the follow, Kapow. So I'm going to assume we want to do u equals x or 1 - x. Let's see how that works out though. That means du is equal to minus dx. And I'm doing this because usually we want to simplify the denominator, and whenever problem that's like this, we want to simplify the denominator and to make it so it's only one thing. So I made it 1 minus x. We'll have square root to deal with, but that's okay. And we can still express x plus 1 in terms of u if we do some algebra. So we can rearrange this to also say that x is equal to 1 minus u. And so we can do this 1 minus u over there. I'm not sure exactly if this is going to work out. If it doesn't, then I'm going to consult Wolfram Alpha, but I think this is how we are going to solve this. So we get 1 plus, and then x is 1 minus u. And then on the bottom, we just get root u du. And let's look for some simplifications here, something that we can do. Well, first, 1 plus 1 is 2. Now, where do we go from here? This is simple, but the square root is kind of cramping my style. So, no, like if the square root wasn't there in the numerator, I would want to split this up into two different fractions. But we don't have that. What else can we do? M equals root 2 minus u? Really? Let's try that. I don't know how, where that's gonna go, but I'm sure that you have a good idea of where this will go. So if we try out the stuff that Zach suggests with m equals root 2 minus u, we derive it to get, we multiply the exponent, which is 1/2, and then subtract from the exponent to get -1/2, so 1 over 2 root 2 minus u, and then because of chain rule, we need to multiply by -1, because that's what minus u derives to. So let's stick a negative sign in front. Oh, it's supposed to be dm. Okay. So this is going to be a funny one to apply to the actual integral. So I'm not even going to make this substitution on anything yet. I'm just going to write the original here. And then now I'm going to multiply by that. Sorry, dm now. And I'm just doing this out of caution because I'm not sure where this integral is going, because let's be a bit more clear, that's parentheses. Oh wait, that's not quite right, Zach? Okay. You know what, maybe I should consult Wolfram Alpha on this. Hey Ben. The method's great, like always. I'm trying to work out the integral of square root 1 plus x over root 1 minus x, and we're trying to work out what our u substitution is supposed to be exactly. And I'm going to cheat and use Wolfram Alpha because I don't want to give future traders more bad advice than I already have. Not necessarily bad advice, but just going around in circles, not accomplishing that much yet. Can you chain rule the top and bottom part? No, because neither of them derive to the other directly, as far as I can tell. Oh wait, I flipped the top and bottom. In the concept of integral, basically the reverse is a U sub of the chain rule. Whoa, really? They do this sub? Really? I wish I could. Oh man. Okay, this is another part where it'd be helpful to have Wolfram Alpha Pro, because I mean, I could just give it. Well, no, it's gonna be a little bit annoying. I mean, actually, I could do their very first step, which is putting everything underneath the radical, and they might do that. They might show one more step after that. So yeah, you definitely try that, Futures Trader. I just want to see where it's going to go, because that seems like a very odd U sub. And this is a very different answer from the one that we just got. It might not actually be that bad. Sometimes Wolfram Alpha does weird things with its simplifications. Huh. Sorry, I'm just checking one thing on Discord. I feel like there should be a different way to integrate this. Okay. I heard like Dan singing that site's praises. I've never actually been to it for myself. Wow, that's a complicated integral. I'm glad I don't have to do that one. 1 plus x over square root 1 minus x. Yeah, we chose a nice challenging one there, Futures. Anything wrong with that? Wait, manually computed?
Beautiful.
Wow, whoa, that's an even weirder sub. What? Okay, they also, oh wait, they let you do with different substitutions? That's pretty cool. Yeah, I mean, this... Okay, let's try it with the sub that we tried. Let's see how that looks. It boils down to something pretty nice, but getting there is a little tricky. Okay, so we got to this step on our own at least. What do they do? Oh, I would never think to do a sub like that. I'm glad we looked this up. I think it's much easier for a human to do this with multiple subs. A computer, can skip steps and do just one big sub, but I mean, this is still a little much. Do you have to do this for what context were you giving this problem, Futures? Like what class or something like that? We can definitely work through this, but you're giving this in Calculus 1? I'm sorry you have to do this in Calculus 1. Oh my god. Oh, there's also a black pen, red pen video. Oh, thank god. My browser's gonna take a while. You're from Austria. Oh, okay.
Let's integrate square root of 1 minus x over 1 plus x. As we can see, we have a
You guys are
rational
geniuses over there. I don't know what
without
to tell
the
you.
square root, and that makes it
Oh
pretty
wait, he has the oh no, this is the flipped. The 1 minus x is on top there. The technique might still be similar though. Oh sorry, so I'm not showing them both, but I just copy pasted what because Futures initially put it in that format, but they said then that's actually like the flipped version. I wonder if that would still work. Maybe not. Maybe you do it with 1 minus x over 1 minus x instead. Oh, actually in this case they both work. Huh. I kind of want to try that. That might make it a lot simpler. Splitting up into two. That one's a trig sub. That one's a u sub. Actually, oh no, that's just the definition of arcsine. Oh, okay. Let's see if that works. That'd be a lot. Oh, I'm sorry. I'm not even showing my browser. I'm so bad with that. So basically, he did two separate versions. One with multiplying the top and bottom by 1 plus x over 1 plus x. The other one multiplying top and bottom by 1 minus x over 1 minus x. And going down the case, like I feel like I hope something like this would work for our problem here. What? Wait, how does he do
So that's the answer.
the right side?
That's
Maybe he said just focus on the left, or I'm sorry, I don't know my lefts and rights. I guess the left is a lot harder, and this way is much easier. So should do whatever gives you a screw on the bottom. Okay, maybe let's try that. See, that's not the same exact problem. We could still try that technique. There's my marker. I'm gonna erase this. I think it's okay. This work isn't anything that special. Okay, so I'm gonna come over here and rewrite this as one big square root, which you're allowed to do with exponent rules. Well, let me not close off the square root yet. I'm gonna multiply. I think we're gonna multiply by the numerator here. 1 plus x over 1 plus x. It's over x plus 1, but it's all the same. And 1 plus x squared, square rooted, is just 1 plus x. And on the bottom, we have a difference of two squares situation. 1 minus x squared dx. Oh, wow. So this is going to work out pretty nicely too. Okay. So we split up the fraction into two based off the numerator. So 1 over root 1 minus x squared plus x over root 1 minus x squared dx. Oh my god, that's so much simpler. So that's a really clever step. And 1 over root 1 minus x squared is arcsine. Just, I'm not going to go through how to get that because it would take me too long to remember, but that first one becomes arcsine. Of x, and then that one we have to do a u sub for. U equals 1 minus x squared. Du is minus 2x dx. Multiply by one trig, exactly. I don't feel that bad for not spelling it because you didn't, like we were both thinking to do a u sub at first, so I'm glad I'm not alone in my instinct to try to, or like I didn't think to look for that kind of thing at first. So what does this boil down to? So we get minus a half in front. I'm going to bring it outside the integral. The x cancels with the x. 1 over root u du. Okay. So that's equal to arc sine x minus. The u comes up to the top and you multiply by 2, so that 1/2 goes away. And you get root u. I mean, we can do a plus c, but I'll do it at the end. Arc sine x, that's unsub. U is root 1 minus x squared. Plus c. Okay, that's so much easier. Oh my god. So, if you don't see that trick, futures, I didn't either. That's definitely the simplest way to do it, unless your computer doesn't mind doing a mountain of algebra. To do it a more natural way. But yeah, I don't have a good trick to spot that kind of situation because it's just, it doesn't come up that frequently. So I'm sorry that I can't give you better like general advice for encountering integrals that are like this, but I guess now you've at least seen this one and maybe it'll trigger something if you see a similar one on a test or something. I'm sorry, just checking my Discord because I want to see if I'm getting pinged for a certain reason or if it was just like not everyone. Okay, there's just not everyone. I don't care that much about it. Okay, so if that makes sense to you, futures, I'm gonna go back to this other. Actually, I should make sure that no one else is posted in that thread. We're working on this initially. This surface area of revolution. We have to do this annoying integral. I'm gonna erase this work. Yeah. Okay. So where was I with this? I had just worked out the integral secant cubed using integration by parts. And I also subtracted the integral secant theta. So this entire integral is equal to this. And I was dealing with unsubbing. Oh, you know, I shouldn't have rewritten, or maybe I should. I just realized the bounds here aren't right. So I did a theta sub. Shouldn't have written them like that. So what should we do here? We can do that theta equals arc secant t. Then we're gonna have tangent of arc secant. And we can deal with that, I guess. I guess we have to. Okay. Theta equals arc secant t. Basically rearranging that equation for down there. Secant is 1 over cosine, cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. We do need to do a right triangle here. We call this theta, that a right angle. I already forgot what I said about it's hypotenuse over adjacent, so t over 1. That means hypotenuse is t, adjacent is 1, opposite is, by Pythagorean theorem, t squared minus 1. Makes sense to me. Okay. So when we come down here and we unsub, I'm going to do a good amount of this just in my head because it's going to be a lot of writing if I don't. Secant of arcsecant of t is just t. Tangent of arcsecant of t, we refer to this triangle, we take our theta, we do opposite over adjacent. So tangent of this theta is root t squared minus 1 over 1, which is just root t squared minus 1. Minus 1/2 ln absolute value. Same thing, secant of arcsecant is t. Tangent of arcsecant becomes root t squared minus 1 absolute value. And I assume, oh, from 1 to x. Don't forget that. Ben, how's it going? Okay, so now let's plug in our bounds. This is all in the name of finding what the heck our y is, and then we're gonna have to integrate this again. There's no way this is what you're supposed to do, right? This is ridiculous. Okay. Let's just try it and see what we get. Maybe it won't be that bad. Root x squared minus 1 minus 1/2 ln x plus root x squared minus 1 absolute value. When you plug in 1, you get 0 there. You get ln of 1 is 0, so we don't need to worry about the lower bound of 1. Okay, so all this is y equals that. And I did all this because we need to figure out what y equals in this integral. So the thing we just integrated, we're gonna have to integrate again, but with an x in the mix. There's no way you're supposed to do that. That's way too complicated, right? Am I missing something? Let me... So I was hoping we would get some kind of neat cancellation with whatever this happened to be, but it's just an x. Okay, so I'm not missing anything, I don't think. I'm gonna write back to this person and ask them if this is everything that they were given for the problem. Like, I don't know exactly how the question was phrased, because this is a lot. Okay. Radius of convergence, let's see. We can do this. Yeah, for radius of convergence, you almost 99.9% of the time you use the ratio test. Maybe sometimes you use the root test for really specific functions, but let's find the radius of convergence for this series. I haven't done it in a minute, but I don't think it's going to be that bad. All this work, I'm going to erase it. Dude, the integrals today have been crazy. Oh, you know what? I never accepted Skirtle's color redeem. There we go. Okay, back to black. So, radius of convergence of the power series. N equals 1 to infinity of 2n parentheses factorial over n, wait, n to the 2n? Okay. I assume it's like that, and not n squared times n, because that'd be weird to have, I'll just make it n cubed. Times x to the n. Okay, so we want to know for what values of x this series will converge. We do that using the ratio test, which is basically you set up the limit as n goes to infinity of the absolute value of that series, the entire thing, but you do n plus 1 instead of n. Like that, or where you see n up there, you make it n plus 1 over the original. Okay, and the ratio test only converges when this evaluates to be less than 1. So we said equal to, or we set it to be less than 1, not equal to 1. And now we need to, I guess, solve this for x. So first things first, x to the n plus 1 over x to the n is just x to the 1. And x to the 1 doesn't involve n at all, so it actually come outside the limit. It does need its own absolute value bars, but that's okay. So absolute value of x times the limit as n goes to infinity. And now we have like basically the left part of the problem to deal with. And we have no alternating, we have no negative numbers here. N is always positive. So these don't actually need the absolute value bars for our n's now. I'm going to multiply the 2 inside there, so 2n plus 2 factorial over n plus 1 times 2n plus 2 over 2n factorial over n to the 2n. Okay, less than 1. So I think the next step is the one that the person is probably having a hard time understanding. So let's draw it out a little bit on the board. Help us explain it to the person once we do go to write our post. Well, point. Let's do one other step to get rid of this fraction of a fraction nonsense, and then we'll do what I'm thinking. The bottom comes all the way up to the top, so n to the 2n. That top comes to the bottom there. I'm going to write it over here, so 2n factorial. N plus 1 to the 2n plus 2. Less than 1. Absolute the value of x, limit as n goes to infinity. So 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n times 2n minus 1, dot dot dot. And then we have n to the 2n over. Now 2n factorial is equal to 2n times 2n minus 1 times 2n minus 2, and so on, just like that. And then we have times n plus 1 to the 2n plus 2. So what we have to notice here is that this 2n, 2n plus 2n minus 1 matches this 2n, 2n minus 1, and the pattern is going to repeat, and they're all going to match each other. So we get a whole slew of cancellations here. We're only left with 2n plus 2 times 2n plus 1. For those ends, I'm not sure how we're going to deal with them yet. I'm worrying about that later. Limit as n goes to infinity. Oops, 2n plus 2, 2n plus 1, into the 2n over n plus 1 to the 2n plus 2 is less than 1. Okay, so this is a mess. How do we evaluate this limit? We can get a bit of a cancellation here because we can factor out a 2 from that. That'll become 2 times n plus 1. So we have an n plus 1 on top and an n plus 1 on bottom. But I don't get us much closer to actually evaluating this limit. We might need to do some fancy exponentiation and logarithm stuff. Let's do the first simplification that I said. So I'm going to factor the 2 out from that term. 2n plus 1, and cancel it with the bottom. 2n plus 1 now, because we had a cancellation. Now, I don't see a particular way around doing some e to the ln business, which is unfortunate. Maybe it's not unfortunate. It might not be that bad. Let's try it. So when you have something like x to the power of x, as far as I know, the only way to evaluate that is by manipulating it a little bit. Basically, you do e to the power of that, but you have to keep things equivalent. So, ooh, actually, it's not this simple, is it? We need to do some more manipulations on this. We want to get our exponents the same here. I think so. So I want my exponents to both be 2n, so I'm going to pull an n plus 1 out, I think. Okay. Still less than 1. Now, oh, it's still not that easy. I think we need to use some limit laws here. Let me, n to the 2n over n plus 1 to the 2n should approach 1. That definitely makes intuitive sense. I don't know if we'd be allowed to just skip to that though, unless I'm saying. Oh, really? It doesn't? Okay. What I was thinking is that, I mean, okay, you guys tell me if you disagree. I was thinking that, so I'm not that familiar with like limit laws when you are and aren't allowed to do things, but I think we need to split up the limit to be like the product of two limits with like the non-exponents as one limit and the exponents as the other, and then do the e to the power of ln. It's the only way I can see to possibly work with this thing. But I'm not that strong on like when you're allowed to do that product thing or not. Like I've just like seen other people do it, so I assume that you can do it all the time. Maybe there's a different way that we can simplify this. If we could group the n over n plus 1 in big parentheses and make it to the 2n. We don't really get a cancellation or any simplification out of that, do we? You see it now, Zach? Well, at least what I'm thinking, and if I'm doing something catastrophically wrong, is we turn it into 2, limit as n goes to infinity, 2n plus 1 over n plus 1 times the limit as n goes to infinity of n to the 2n over n plus 1 to the 2n. I don't know if that part's allowed, but if we can do that, then this we could do with exponentials, or e. Really, so you do want to do that, Zone Ranger? I don't know what that gets you. Oh, I mean, for this part, yes, because then that helps you with the e to the ln. Oh, you get the definition of e? Oh. Okay. Or the reciprocal. So then we get e to the negative 2. If I'm not crazy. Or you could, I guess, divide them. Like Zone Ranger did. Or does that come out to be 1 minus e? Squared? Dude, I only know that like the base, like when you get a limit that equals e, I don't know the other like formats. So I'm sorry that I'm not like getting it. All right, so you, wait, 1 plus 1 over n to the n. But if you divide them and get 1 minus 1 over n plus 1, those come out to be the same? same as e. Oh yeah, so I see how that comes out to be e squared. I just don't get. Okay, so I guess let me like draw it out. So I mean that's just gonna evaluate to be 4, right? So we can just take care of that. This, I can see how we can, you know, group the exponent and divide n by n plus 1 to get 1 minus 1 over n plus 1 to the 2n. It's less than 1. And then I know that you can, like, you know, take the 2 and put it outside in its own parentheses, but I don't see how this becomes 1 plus 1 over n. That's the part that I'm confused on. Yours is the reciprocal. Oh, okay, so that's why I'm not, okay. So, well then, in the case, do I want to divide it like zone range did, or I just want to work with this and make the exponent negative and flip it? That would make more sense to me, at least. If I did n plus 1 over n to the minus 2n. And then now you can split it up based on the numerator. Like that? That makes sense to me, at least? I hope. So we get 4e to the negative 2. Absolute value of x is less than 1. And then, so we get absolute value of x is less than 2. This is a mean one to give to a student, but e squared. So I guess that's just your radius of convergence for right there, and that was the question. You don't need to worry about the start and end points and whether they converge or diverge. Okay. Thank you both for helping with that. Those are definitely saves. Okay. Oh, watch this. Someone probably beat me to this. Okay, so someone did respond, but I want to... They mentioned factorials that they have a difficult time dealing with, so I think we can address that part without needing to know their work. Oh, you're right, Jed. Thank you. I forgot to expand that. Dude, I am not on it today. I woke up too early this morning. So yeah, they say that, so there's this person who beat me to it, but they just said, like, you know, you show us your work, which is fair, but the person did say they're not very good with factorials. And so I think we can address that part for sure. And probably give them a hint about the limit because it's a little difficult. So I think I'm going to give them just the factorials part of what's happening in this problem and maybe leave off the rest, or I'll just give a more general hint for what they should do. The ratio test for this problem. You get 2n plus 1 factorial over 2n factorial, among other things, but I'm focusing just on the factorials. First, I'd multiply the 2 into the n plus 1 to get 2n plus 2 factorial over 2n factorial. At this point, we need to remember the definition of a factorial and expand them out to get 2n plus 2 times 2n plus 1 times 2n times 2n minus 1. I'll do even one more term there. Over, oh wait, dot dot dot, over 2n, 2n minus 1, 2n minus 2, dot dot dot. Pattern is the important part. We can see that besides the 2n plus 2, 2n plus 1 on top, all the terms will cancel, leaving us with just the 2n plus 2 times 2n plus 1. That's true, Jed. Is there a situation where one explanation is better than the other? I'm trying to think. So you get some weird factorials. Well, I guess we do have some weird factorials here with even odd numbers, but sometimes you don't get the factorial. Or I don't think of. Yeah, it is a lot easier to type in a Reddit comment too. I think it's. I definitely have had serious problems where they don't give you factorial, but they'll give you like 1 times 2 times 3 times 5. But I do like your explanation more, I think, regardless. Um, 2n plus 2 factorial is equal to 2n plus 2 times 2n plus 1 factorial. Things like that, Jed, I guess. Like, I feel like my class, it's the problem that I encountered. I never had to like work backwards like that. They sometimes give you like a string of numbers that are in a pattern, but they don't happen to be the factorial pattern. As part of your series. But even then, I don't think that's that relevant to this problem anyway, so I don't think we need to worry about it. I still say it outside in quotes. All this stuff can actually go. Yeah. Have we proven that, or is that a definition? I thought we just say that 0 factorial is 1. There's no reason we couldn't define it to be something else. It just would be weird and break a lot of formulas. My recommendation is break it up into a product of two limits at a certain point, and think of the limit definition of E. And I think that's all I'm going to say on the rest of the limit without them saying a bit more about their work and what they've tried. Okay. This is binomial, isn't it? Characteristic values? That's probably a good word for it too. Or that's like about the same. Reject your reality and replace it with my own. Oh, that might be a good soundbite. Like a channel point redeem or something. Actually, I think I was gonna make that an alert. I don't remember why I didn't though. Oh, I could have found a good clip, I think. Oh well. It was something like that. I remember I looked for it, but I didn't end up doing it for some reason. So I think you would do a binomial distribution for like up to and including 0.505 times a million minus up to and including, I guess, 0.49. You do 49, I guess 495 because it's probability is continuous case for a scan times a million. No man, but well, the variance, a normal approximation. Oh, that's good call zone. Thank you. I always forget about that. And so yeah, they're gonna have to use root and PQ, and P and Q are both 0.5. I think it's standard deviation rather than the variance. Let me. I am gonna look this up though, because I don't want to tell this person the wrong thing. Yeah, okay, so it is root and PQ. All right, Zone, thanks so much for helping out with the problems. Enjoy your food. Actually, for the variance of a binomial, isn't it the same thing? Yeah, it is. Make sure you don't.
You cut the shit out of it!
I was wondering where you were going with that. Okay, that's more like it. Shit. Square root n is p times 1 minus p. N equals 1, 1, 2, 3, 1, 2, 3. Wait, can I count? Is that actually 3 zeros? I've already, okay, yeah. Actually, they're probably already using normal distribution. That's not the standard deviation, right? Because you don't need the standard deviation if you're just doing normal binomial stuff. So maybe I'll just leave it at that. That was help 12 punj, whatever that means. Yeah, that basically covers it.
Everybody in the groove. Well, stick around. We're just warming up, baby. Okay. Trig angle formulas for surface. Yeah, for that one, for that last triangle, I'm gonna have to. I'm not sure. I mean, it's isosceles, so we can just divide it in half and get two right triangles, I guess, to get the height. And we already know the base. What's K? That's K? I haven't seen that notation before. K times sigma. Why do you... Oh, because you want to find how many standard deviations away it is? It's a weird way of putting it. Hey, Pen Center. Nothing much with me. How about you? How do we work out? Isn't that... It's the z-score, right? That's how many standard deviations away something is? Can we addict to that math channel? It has its flaws, but it seems it's a pretty huge server, and they seem to be running it as well as you can run a huge group of people like that. It seems like reverse engineering, like, why? I wonder why I wasn't taught it this way. Oh, maybe this person, you know, that's a good point too. Four root 2 times 2 root 2. It could be. I need to, wait. If we're applying the normal distribution to this, and Bob, I'll check that in a second. I haven't worked it out for myself. we still need to do the 0.495 times a million thing. And the 0.505 times a million thing, I think. Differential equations, ooh. I wasn't taught this, or I wasn't taught this way of doing it, so I'm not sure about that part. We can definitely work out what interval we want to be on. No problem. Let's leave it at that and see what they say from there. Now, going back to this probability one before I try to post the triangle thing if someone doesn't beat me to it. This I've never seen before. It looks pretty analogous to calculating a z-score. Well, the mu is not 1/2 though. The mu is 500,000, isn't it? This seems weird. I don't... Oh, really? Okay, that'd be cool. Yeah, because my solution isn't perfect, so if you come, or the way that I did it, it could be a lot better, so. If you come up with something that's not super janky like mine, I definitely would switch over. Analogous to calculating a z-score. So I have a hard time commenting on that part. I don't have much more to present. Let's go back to the stats. Okay, we're working on it. Oh, we got geometry. Triangular pyramid. AB, BC, BD are perpendicular. Okay. Work out the total surface area. All right, Jed, I'm assuming you are interested in this one. I'm gonna drop a link in chat, because I'm probably gonna switch back and forth between this chat and others. Actually, I mean, I don't have to take out the screen for now, though. Because the other person hasn't replied back yet, so we could try and work this problem out. Perpendicular to each other. So we have right triangles for all the faces that we're looking at. Interesting. Yeah, so we can just find the areas of the 4 triangles in like the two-dimensional case. Actually, and it's not going to be as bad as I'm thinking. We have to make sure that we keep track of what's what properly. Wait, BC is 4. Wait. No, those aren't at a right angle with each other. AC is 5. Oh, okay, yeah. That makes sense. CM is a line. See, maybe I kind of want to draw out each of these triangles. So we got 3 right triangles. B, A, and C. Let's start with triangle ABC. B is always going to be a right angle. AB is 3. BC is 4. So AC is 5, as Jed said. We're going to have 3 more right triangles, all with B as the right angle. We also have CBD. Loves some of that. We have 4 and 4 there, which makes that root 32, which, isn't that 4 root 2? That makes sense, duh, yeah. Two of them are congruent, ADB, ABC. Oh yeah, you're right, because they're both 3, 4, 5. AB again is 3, BD is 4. So yeah, that's a 3, 4, 5 triangle, okay. And then we have the triangle in the bottom, which I think can be anything as far as we know. So I'm just gonna draw a little lopsided. That's not very, very lopsided, but it's kind of ACD. Actually, we know all the sides though. AC is 5. CD is 4 root 2. AD is 5. So it's actually an isosceles, okay. Let me just check the Discord to make sure the person hasn't replied. They actually have. Let me get back to the binomial distribution person quickly. Okay, so back to this quadruple triangle situation. So yeah, this is an isosceles triangle, so we can just cut it in half. Get 2 right triangles, and so that height is square root 5 squared. I don't know why I'm writing out 5 squared. Just make it 25. It's fine. It's root 25. Oh wait, we have to cut the base in half. Okay. 2 root 2 squared is 8. So 16. No, that's just 17. I thought it'd be a nicer number. Wait. Okay, yeah. Okay, I guess it's just root 17. So I'm not sure where that came from, Bob, or if I was thinking about the wrong part. But I think the height of this triangle is root 17. And then it means the area is base 1/2 base times height. Yeah, I don't think I'm doing something catastrophically wrong. Oh, okay, good. Or not good that you messed up, but good that I wasn't going too far off the deep end there. Okay, so the area, the total surface area is 1/2 base times height up there is 6. 1/2 base times height up there is 8. That's 6 again. Here, it's root 17 times 4 root 2 divided by 2. 2 root 2 times root 17 is 2 root 34. So we get 20 plus 2 root. Not the cleanest number, but it's a number. Whoa, that's not what I want to do. I missed the Alt key. I'm sure there's a better way to reset the cropping and zoom of a window, but I don't know it. And I'll figure it out one day when it annoys me enough. Oh yeah, sure, pen center. The height here, it's an isosceles triangle, so I just made the altitude or whatever the word is. And then I did a Pythagorean theorem on this like half, on this right triangle that's half of the isosceles with 5 squared minus 2 root 2 squared, because you divide the base by 2. So 25 minus 8. 1066 to go. Okay, cool. I think the person with the triangles was this person. Which I'm surprised no one got to this one. Okay, so... And thanks, Bob. Honestly, the riddle question I kind of have to be in the mood for. So today I'm not gonna... I'm not in the mood for them, but sometimes they're nice when things are slow. Thank you. Triangular pyramid is just 4 triangles connected together. Could draw out 4 separate triangles. ABC, BCD, ABD, and I should know this without having to look up at my board, right? Like, why can't I, ADC, or ACD, I guess. Sides and use A equals 1/2 base times height. Height? Okay. ABD, they can just do that. Let's see. ABD, 1/2 times 3 times 4. Yep, they can do that. ACD is not a right triangle. Or I shouldn't say right. Correct. Someone else helping with them. 5.08? Root 17 is not 5.0, it's 4 point something. Actually, the base is not 5 for me either.
Keep on saying right. Okay. Way too much work. It's just so much arithmetic. Ugh. The F stands for fun. Yeah, it's reduced fun. Really, really extra fun. No. Oh god. Bring the picture back up for this one, Jed. Oh, look at all their work. I don't want to say this for too long, so if you're gonna take a screenshot or whatever, let me know when you're done. Okay, thank you. Okay, so I was working on this person. So for DC, Route 2. Okay. Wait. It's not hard, it's just a lot of work. And I sometimes get mixed up with like the span if there's because like if you need to parameterize the span, I don't always remember how you do that. So it's more like the questions after that that I don't feel as comfortable with. Well, I mean, I guess you set one of the variables equal to t and you just figure out what the other ones are, but it's still like, I'm not that comfortable with it. Seeing D, B, and B, C. Should be... Oh, wait, okay, I see what they did now. Okay, good. So DC ends up being 4 root 2, right? Okay. To do, yeah. You can round it, but or in my experience, they often the exact solution, which means you keep the square root there without rounding it. It's like
the height I got root 17. This person got 5.08, and root 17 is 4 point something, so. Four root 2, 5.65. Four square root 2. Yes, okay, 5 point. I mean, 5.6 is closer, but you know, I'm not gonna nitpick over 1/100th. That'll do. Really? No worries, Bob. So this person, we've already discussed the length of what, DC? AD and AC, we haven't talked about. That's what I've been trying to ask about, but not doing a good job of, I guess. 2.67, let's see if that matches my answer. I got 20 plus 2 root 34. I'm just putting that into Wolfram Alpha quick. 31.66, what did they say? Oh, yeah, you... Times 5.07. Where did they get the height from? Yeah, oh yeah, there's the 1/2 as well, but let's we can address the 1/2 part after this, I think. Let's go back to this person. They skipped a step here. What's 4 root 2? Did I? Oh yeah, okay. So that 5.65 is basically 4 root 2. But they took a shortcut here that they're not supposed to. Why did it? Oh yeah, and so they actually drew the wrong height. That isn't the actual height there. AD is. And we can work on how to draw the height. So we can't just draw a line from one corner to the other side and call it a height without knowing the entire... Okay, AD is 5. Perfect. So AD is 5, AC is 5, and DC, or CD, or DC is 5.65 to use their number that I'd rather not use, but since two sides are equal, this is actually an isosceles triangle. And height of an isosceles triangle like this by drawing a line from A down to line BC, which divides it into two right triangles. Let's leave it at that and see what they say, I think. The way that I was taught Simpsons rule, I think, was like with that parabola like connection. They didn't really explain it much other than vaguely it involves parabolas, but that is something like I associated with Simpsons rule because the way it was taught. Okay, height is 4.12. Check what root 17 is. I'm just gonna do it quickly in Wolfram. I don't want to bother changing my windows. 4.12. 4.2. A. Okay. All right. Perfect. I said perfect right before that. I'm really bad about just repeating my same like few words. Awesome. That's right. There we go. You know, gotta vary our responses. Or, I mean, that feels like a final. No. You say that when they got into the very like the final answer, not just like a step along the way, right? Source. I needed the source. Yep. There we go. Yep is a good one too. Do 1/2 times 4.12 times. It's 4 root 2 is the base, and they said 5.66. Or 5.65 root 2. 665. Okay. Wait. 5.65 divided by 2? That's not right. Like 5.65 divided by 2? Your life is formed from an orthonormal basis. I was just a car that's passing by and not my neighbor. Someone's blasting music right now. 2.825. CAD is 1/2 base, or 1/2 times base times. Oh wait. Oh no, I'm wrong. Oops, I was getting my steps mixed up. I was saying that to get the final area of ACD, they should still divide the 4 root 2 divided by 2, and you don't do that. Okay. $31.46. It kind of pains me to not use radicals, but let's check. 31.46 against 20 plus 2 root 34. $31.66? Is that basically what I got? 31.46. I think that's basically right. Uh, 31.66. I think that's enough to say. $3A and 6B they need help with. Oh, okay. Uniformly from 18 to 30. Okay, so we got some more probability. Which isn't my favorite. For 3A. Let's start with this one. Relative frequency. So basically you need to, that's where you say like what percent something, a certain value came up, but when you're given data like this, you kind of need to make buckets, it feels like. Which, I mean, I guess that's fine. I would hope that's still a huge amount of numbers to punch into a calculator, though. But there's no other way around it. Actually, but dude, oh man, I'm trying to remember like calculators if they'll make buckets for you. Like, how do they calculate them? I assume they would. I just don't remember how that part works. Let's use Excel. Yeah, I mean, that person's the one who'd have to copy down each individual like data point, which I don't envy. Oh yeah, how is the answer for 6B 5/6? Uniform distribution but from 18 to 30. Part B says at least 28, which is only a tiny part of the uniform distribution. 28 to 30 is not 5/6 of that
interval. So I don't get what's happening there. I kind of want to just scoop by this question because I don't feel that confident in answering either of them. And 3A especially, I think it's going to depend on the class, how they're supposed to do it. Two over 12 is 1/6, but they said the answer was 5/6, which is like the reverse. So maybe the answer key is wrong or something, or misinterpreting it. I'm not sure which one. Yeah. I guess 6 would be more than? Well, we have at least 28. Oh, less than. Okay, yeah. That. Yeah, it would be. So, I don't know. Oh, this is the triangles. Okay. Create buckets with ranges of values and count how many times a data point falls in that range. Then calculate what % of the total each bucket has. Usually, teachers will let you use a calculator to do this for you. For 6B, it does. You're confused now? Yeah, they must have flipped the probability. Or I guess at most 28 hours. Yeah, PhD. Okay, so let's see what's up with this person. I did? Error key. Oh, I see. There's an answer in the answer key. Oh my god. Refer to your error key, student. Thank you. I didn't know that. Okay, I did not at all see that I made that typo. Thank you for catching that. God. That's what I want to make an error key for a textbook. Just all the errors you can make on a problem. Oh. No, that's like working out like it's discrete, but this is continuous. I assume that's the issue here. Let me see how the, okay. I just say the formula is like generally represented.
So I know like the line is like 1 over b minus a, but when you actually want to do the probability, I know what it should look like. But like, I want to see how they usually... d minus c over b minus a. Yeah, that could be a good one, or a good way to explain it. Same way. It'd be more like 28 to 29 is one, and 29 to 30 is another, and everything in between. I can ask them what if they were given a formula for doing this too. That might be better than me trying to Google it. Hopefully you have a. Hopefully your teacher gave you the formula to calculate with uniform distributions. It's like I know intuitively that like from 20 to 30 is 1/6 of the interval, but I have a hard time like actually expressing that in a way that a stats student like would hopefully be comfortable with. Sometimes they want to avoid kind of like the I guess intuition way that I'm thinking of. But we'll see if they ask what the formula is and then address it then. So I want to come back to this because this person I think replied. Okay, they said they might say more, but for now they're okay. Stratified sample. Doesn't this depend on the class? I guess you're doing it proportionally if you're stratifying it. Okay, I did see that. I have a reply now. If you're choosing 80 children, you do, I guess you could add them together. 150 plus 250 is 400, and then do 250 over 400 times 80. I assume that's what they want. I feel like that's... Every one of the parts is a multiple of 8. Wait, for the triangles? In a stratified sample? Oh, okay. So that probably is what you're supposed to do then. Oh yeah, you're right. So, yeah, because they're over 400, so that's 50. Okay, I mean, I feel like it still could, like, there still could be some kind of weird thing. They're supposed to do it somewhere else, but I'm pretty sure this is how you're supposed to, you're supposed to add the total pop. Well, I think we need to get like what percent are girls and what percent are boys, and so the percent of girls is 250 over the total 400 is what I would think of. Yes, that's the thing. Like, when I did stratified sample, it was kind of vague and not particular to a specific thing. Oh yeah, sorry, Penn Center. So I think they would want to do it proportionally. So that's, if you want your own copy, it's that there, but I'll bring it up on stream too. And I'll make that bigger, but it's going to be kind of blurry. What? Wait, where did you go? Okay, right there. Okay, hopefully that's a bit more readable. Stratified is just where you, instead of complete random sampling, you divide it up a bit by a category. And actually, there's enough room where oh no, that doesn't work because I have the Discord on top. So the only thing that I can think of that you're supposed to do is to get the proportions of boys and or the percent of like girls and boys and multiply it by the total. But like, as far as I know, stratified sample could be kind of arbitrary. So, oh, and they closed it. Never mind. So I guess we get to avoid that question, but they reopened it. Yeah, and so that's what I want to do, Bob, but it doesn't necessarily have to be that way as far as I know. Okay, I assume it got closed. Okay, so let's come back to this person. So I think for a stats student, they would like Bob's approach of getting the percents rather than trying to deal with proportions and the arithmetic of fractions. Is my guess. I mean, not every stats student is going to be like that, but many of them are. So I think that I'm going to go with trying to do percents, and if that isn't working, then we can try the proportion way. 80 times the percent of girls to find how many girls you would sample, and the same for boys. Okay. Oh, I didn't even see the chain rule one. Oh, good. So they knew how to work out the percents. Oh, that's a good point, Penn Center. Okay. I didn't even think about that. That looks about good to me. Personally, I would do it like the fraction way, but it's all a matter of preference, and I think this is a lot easier for people to get. I guess I can verify it too. Let's go the extra mile here. 250 over 400. Oh, this isn't really the extra mile, I guess, but 250 over 400 is what? And I know I'm not showing this right now. 508.625. Okay, good. So yeah, they get the right percents, and 0.625 I'll do times 80, and then I'm gonna call that enough for checking their work. 0.625 times 80. It's 50. Good. Looks perfect. Ugh. Okay, so that person got their help.
Wait. We have 3 data points? And we think we know enough to say that it's quadratic? That feels very wrong. You know, with 3 data points, you can do interpolation. Let's see. Okay, this doesn't feel very realistic, but let me just look up parabolic or quadratic interpolation. I think it's the better word. Yeah, it's it must be that peach tea. To be fair, if it does work for a quadratic, I don't think it can't be a sneaky like logarithm or something like that. Or, you know, there's also a logarithm curve that fits. But that like, in terms of like stats, that feels very wrong. Okay, so yeah, I remember having to do parabolic or quadratic interpolation, but computers always did it for me. And the calculations are a little complicated. Just do Gauss or something? Does he have a way to do interpolation? You can go from 3 systems with 3 variables. Oh, okay. 3 points to a parabola. Or as long as the points fit. Or you can, is it any 3 points you can attach a parabola? Not any 3, because they can't be collinear, unless you want to count parabolas in line for some reason. Someone else is typing, maybe I should let them type. I definitely don't want to be another voice also answering the question, I guess. Okay, people aren't helping the person. They're not answering this person's question. Intelligent. I'm not nerdy enough. I'm working on it. Any 3 points and attach a parabola to them. As long as they aren't in a straight line. This is called quadratic interpolation and is messy enough to usually be done by a computer program. If you want to look it up. Okay. Oh, what people are going to think my new Discord profile picture too. Okay. So I kind of want to wrap things up soon here. Oh, it's every time I say I want to wrap things up soon, someone that I've been helping asks if I can help with one more. Yeah, you know what? Sure. Sure. And I was writing sure like that without caps or any punctuation, passive aggressive. I feel like I can come off like that in text. I don't know. It's my stuff before that was like properly capitalized and all that, so I think it's fine. Oh God, what's happening here? Is this a toilet paper tube? It was a sewer pipe. Let me make it a bit bigger, because it might be hard to read on stream right now.
That's a bit better. Then I'll make it even bigger. Actually, I could easily do one of these bad boys. There we go. Sewer pipes used in construction are made from concrete. Are they? Okay. Oh yeah, I guess so. If I'm imagining like the big ones. Oh. Inside, outside, and both ends. Oh, okay. So we know the outer radius, we know the length. Ooh. There's some tricks here. Because you need to be careful about how you count the area here. You don't want to accidentally double count some area, and I think there's a definite risk of doing that. Surface area of cylinder. So surface area of cylinder is 2 pi RH, which is basically all the sides, plus 2 pi r squared, which is the top and the bottom. Okay, yeah, so it is just like length times width, but the thing is, we don't necessarily want 2 pi r squared for the tops and bottoms because we don't have complete circles for the tops and bottoms. And I'm trying to think of the best way that I can explain. Honestly, Bob, that's what I want to do too. They're called washers. Oh, okay, yeah, that makes sense. I assume the person doesn't know like that specific formula or like that thing. They're supposed to work it out just based off a cylinder. So I think I want to explain the formula for surface area of a cylinder to this person and hopefully show why we don't need the 2 pi r squared or we need to modify that part of it. Okay. Let's go back to Discord. Going to need to and while I'm waiting for that person to reply, let's work out what the actual answer is going to be. Just so as they type back, we can tell them quickly if they're right or wrong. Oh, the person's already typing back. HT 2 pi R1 R2H plus 2 pi R1 squared. Oh, okay. Yeah, if like the R1 comma R2 thing means doing it like twice, one with each of the values, I think that's perfect, and that's what I want to guide. Okay, yeah, that's basically what I want to guide the person to doing here. With paint rather than trying to fill it up with water or something. With paints, which means surface area, and then trying to fill it with water or something, which would mean volume. Oh yeah, R1. I understood what you mean there. I didn't like check it to like that level, but yeah, you're right. Putting with paint usually refers to surface area. I want to phrase it a bit nicer. Surface area. Okay. So, I'll quickly redraw this, I guess. Such a gifted artist. Oh my god. Right as I say that, I go off the deep end with my circle. Yeah, I'm such a gifted artist that the world wants to see another drawing from me, even if it's just a sewer pipe. So the length is 8.5 meters. What? Like meters? What even are these units? They don't even mean anything. They're so hard to do anything with. The inner radius is 2.3 meters. U. And the outer, or the, I guess, yeah, the outer is 2.5 meters. Okay, and so the surface area of this thing is going to be, what did I say, 2 pi RL? 2 pi RH, yeah, LH, who cares? 2 pi times, I'll do the bigger one first, 2.5 times 8.5 plus 2 pi times 2.3 times 8.5 plus, and then we'll do either end, well, both ends, the big radius, so 2 times pi r squared, because pi r squared is the area of one circle. In this case, we'll do the big one, so 2.5 squared, minus the areas of the small circles, 2 pi 2.3 squared. Okay. And I'm going to plug that into Wolfram Alpha and see what it spits out. Two pi, 2.5, 8.5. Let's 2 pi. 2.3, 8.5. Plus 2 pi times 2.5 squared minus 2 pi times 2.3 squared. All right, so this person likes to work in decimals, so we know they should end up with 262.39. It doesn't give me the answer in terms of pi? Oh, Wolfram. For shame. Because I don't know if I should say something now or if they're working on it. Maybe let's give it a few more minutes, and if we don't hear anything, then we can ask. For now, we can see if there's any like relatively quicker ones around here. Oh, that's a neat command. Log rules? Wow. Oh, it's particular to them, maybe. Yeah, I like this. I've seen in documentation for the bot, there's something called like a preamble, something like that you can apparently customize. So I assume it's what this person did. Limit laws are ooh. Oh wait, so maybe it's not particular to that person. Okay. I don't know, someone else answering it. Oh, I didn't know there was LaTeX for canceling. That's nice. I'm about to say that I should remember that, but I already know I'm gonna forget about it in like 2 seconds. Why are they talking about Stack Overflow? I don't know. Are they waiting for me to get back to them? I won't be here all day, so maybe I will type. Oh, speak of the devil. Okay. Two times I times R times H is the walls of the cylinder, and the 2 times pi times R squared is either end of the cylinder. Since the area of a circle is pi times R squared. Important to know because we're going to have to cylinder of pipe instead. So no, Jed. What I basically did is on the whiteboard, where I did the outer walls plus the inner walls plus 2 times the big radius minus 2 times the small radius. So I did every last thing like individually, I guess. So the person is saying they still don't understand why it isn't volume, which I'm coming up with another explanation for that. What I said before didn't make sense. Yeah, Peachy, that might be a good way of saying it. Let's try that. Cylinder. Yeah, I think that's a good one. So thank you for suggesting that. See if that works for them. Okay, good. Peach tea, you know, that's a save. I mean, it should have been a save regardless of what they said, because it's still a good idea, but... There you go. So we're actually going to have to use the surface area equation. So we're gonna have to have a few extra things. We need a 2 pi times r times h for the outer walls, plus 1 for the inner walls, and deal with the cut out circles on either end. This one, it's a little bit hard to understand it, so I don't mind kind of like giving them a bit more than a like guiding them a bit more through it than I normally would. Hey, Pen Center. I was wondering who was like typing. They don't mention anything about that, so I'm not gonna mention it to that person. But you're helping with 29? Oh, nice. Just being a weirdo? Oh, okay. I mean, nothing wrong with being weird sometimes. Stream sniped? Yeah. Yeah, Jed, I don't think we need to worry about the thickness of the paint. I would hope not. So... two times pi times 3.5, or no, 2.5, there we go, times 8.5. So I don't know, That part makes sense so far. Calculating that and the area for the inner part of the pipe. Then we can do the ends afterward.
So kind of breaks up into like two different pieces, one for the inside and outside wall since they're very similar, and then another part for the ends.
I should probably get the individual calculations too while we're waiting. Two pi times 2.5 times 8.5. $172.79. I go. $133.52.
Oh, they might have done plus each other. $256.35. Oh, never mind. 32.5. Bigger one. 2 times 3.14. 2.5 times 8.5. Okay, yeah, I think we made an entry error. Oh no, I was trying to say that we're modifying that. Can we just do... No, we can't. I was wondering if we just do the surface area of the outer minus the surface area of the inner, but that's not right either. The second part, 2 pi r squared, doesn't match with a pipe. It's for a cylinder with without a hole cut in it. Okay. Okay, sorry. I'll just say that. Why not? Going past that part.
the surface area or the walls of the cylinder in the 2 times pi times r squared is for either end. Assuming it's a perfect cylinder with no hole in it. That's what I'm trying to get them to, Jed, but we got to get on the same page with what the formula actually means and why we're modifying it. Actually, I mean, I guess I can say that a bit more now. I'm trying to separately pick out the areas of the outer wall, the inner wall, and either end of it. The normal formula doesn't have that issue. But we do in this case. Ow. Okay, hopefully that makes sense. Thanks, Jed, for that suggestion with explicitly saying that I'm trying to divide it up into sections like that. I think I did at some point, but I think I did say it at first, but then there's a different misunderstanding. Okay, I think they asked again about the surface area versus volume thing, and maybe they didn't completely read the thing before. They didn't understand it at the time, but either way, it doesn't matter. 2 times pi times 2.5 times 8.5. See, it's like I want to like look through others so I have something to do in the meantime, but I also don't want to get bogged down in another really long back and forth. So I guess we can still look. There's no harm in it. I might not respond if it looks like it's going to be too in depth. There's not even that much happening around here anyway now. People don't have questions anymore. metric tensor, oh gosh.
Okay, this person still hasn't typed back. Let me, there's not much else going on in the Discord now. It's calmed down a lot. I just start saying that I'm gonna have to go soon. And maybe put the solution in there. Because I do kind of go and eat. I don't have any replies on Reddit. We can take a little look around still though. I don't know why I'm going there. Come on. Alright, see you, Penn Center. Thanks for hanging out. Really? Why can't you just say this is obvious? I mean, I know why you can't say this is obvious, but like, why can't this just be obvious, you know? Do we really have to prove this?
It's a day old and no answer? Okay.
Oh, actually, this person got back to me. I'll get that one after.
Either end of the pipe is a circle. Oh, let me check that. 122.8. Good. Or I get that too. Do one for the bigger, or one for the outer radius, and subtract the one for the inner radius. Or so we can get the big circle with pi times 2.5 squared, and then subtract out the area of the smaller circle with pi times 2.3 squared. See if they can work it out a bit from there, but I'm starting to get in the mode where I'm just going to start saying answers because getting hungry. And they've been pretty engaged in trying to understand it, I think. Actually, you know, let me... Oh, dang it. Okay, let's see. Oh gosh. Okay. Or they're not eating. What? Okay. Wait. I mean, I want to help them understand this question. It's just I'm just like getting tired myself here. Okay, so I can start with that. Man, how do I show this? Okay, I think maybe I'm gonna say it's her to show for me visually. Be a ring. Okay, good. I'm glad that worked for them. Okay. Oh, they even did the multiply by 2. Okay. Now that food's on the line, things are moving quick. And then you just add up those in the areas of the inside and outside walls. You have the answer.
It's always one with these whenever I go on the math Discord and get a good like streak of questions going. There's always one person who has like a few questions, which is completely fine. And I you know, I said yes to helping them, and I could have said no at any time. But like, I hate like leaving someone hanging like that. Hopefully this is all they need though.
They might want to confirm their final answer, which I got 262.39. They're probably gonna get something slightly different because they don't like doing things with exact values for whatever reason, but if their class allows it, then I'm not gonna judge it.
I could just say that I have to go now, which I do have to go and put my final answer there.
Let's do that, because I don't know what the person is doing right now. 262.39.
Okay. I think at there I'm gonna leave things. If they reply to me again, I'll just answer it off stream because I do want to end things and get started on dinner. How many people do we have around here? We have 8. Is anyone streaming math right now? Let me look. 262.38. Okay, good.
Yeah. That should be fine.
Okay, good. One person streaming besides me? In like the math category? Let me look for myself, I guess. Oh, I haven't seen this person before. Math practice. Let me look at their stream.